take down this problem. Perform Newton Raphson load flow method and determine the power flow solution for the system given. Take base MVA as 100. You need to take the base MVA as 100. So what they have given? Line they have given from bus 1 to 2. So maximum they will give only 2 buses because if it is Newton Raphson method, the procedure, the algorithm is more, and the time taken for solving the problems also will take more time. So maximum of in your exams, they will ask only 2 bus system to 2 bus system, sometimes three also a little bit. It might take some time. Okay, because 3 cross 3 matrix will come. So that matrix and all will take some time, but the maximum they will ask for 2 buses only. So here, what they will given from bus 1 to 2. Next resistance values is given in the per unit 0.0839. Reactance value also given in the per unit 0.5183. Next, offline charging admittance value also given. Offline charging admittance value is given, that is 0.0636. Next, that bus data is given, bus 1 and 2. PL and QL is given. That is, this is 90 MVA. Here QL is 20 for bus 2. This PL is 30 MVA. This QL is 10 MVA. So what is the step 1? You need to formulate the Y bus matrix. So from the given data, so first you need to frame what is Z12. Z12 is equal to 0.083 plus J into 0.5183. And also here, offline charging admittance also given. Offline charging admittance also given. That also you need to take into account. So here, what is Y11 is 0 point, because this off line charging admittance for, I think that is for both the buses it seems. Okay, so Y11 and Y22, where is Y22? Yeah. So for both buses, this offline charging admittance is there, because offline charging admittance, if it is given, that is for all the buses. It is not mentioned. So that is for 2 buses also. So here also you'll be having 0.03636. Here also you will be having 0.03636. So that here you are having. And from the data, what is Z12? Z12 is equal to R plus J into Z is equal to R plus J into X. So R is 0.0839 plus J into 0.5183 J. Okay, that is this value. Next, so from the given value, Y11 is equal to only line charging admittance is there, 0.064. So I rounded off here, but you don't round off. You just take as it is given in the problem. Okay. Next, here, so here you have to see of line charging admittance. Admittance itself directly given. So you no need to go for 1 divided by. Directly, you can take that value. If offline charging impedance is being given, you need to go for 1 divided by. So you need to very careful while solving the problem, and also from the given data, whether it is admittance or impedance. So here it is nothing was mentioned, impedance like that, but Z is equal to R plus J into X, that you. So after that you can easily calculate the admittance. If you once you calculate Z, after that you can easily calculate Y. Okay, so that you need to remember while solving the problem. So here you see, yeah, Y11 here. Y12 is equal to 1 divided by Z12, because this is impedance. It is Z. So 1 divided by that Z12. Z12 value is 0.0839 plus 0.5183. Okay. While solving, you will get while solving with your scientific calculator, we'll get the answer as 0.0 3044 minus j into 1.88. Just tell in the comment whether you got the same answer or not. But I rounded off here. You better you don't round off. You take the as it is value, whatever given in the problem. Next step, after that, we frame the bus admittance matrix, that is y11, y12, here minus y12, here also minus 2. So substituting here, this, yeah, y11, y11 plus y1. So here in the bus number 1, it is taken as y11 plus y11, y12. So we added that. So by adding that, you take we got the answer as y11 plus y12. That is 0.064 plus j 0.0344. This already this we already calculated, plus j plus 0.3044 minus j into 1.88. I think, yeah, y12 also then self impedance plus that, see here, this matrix self impedance also there, this thing also there, this element also there. So you need to add the both. Okay, because here offline charging admittance is there, here also impedance is there. So you need to add the both. Okay, so if you add here, you'll get the answer like 0.3044 minus j into 1.816. Okay, so directly you can write this y11 value. Generalized, so that is y11 plus y12. So here, similarly, if this is 0.3044 minus j into 1.816, the same value here also comes. Why? Because there also offline charging admittance is there, and there also only one element is there. So rest are all same, minus of 1 divided by y12, whatever we calculated y12, already value is there, same thing we have taken and written. Now changing this complex, you better you keep it with the complex format itself or change it to polar form, because here it is involved with the phase angle. So what we are doing is we are converting this complex format into this polar form. So in the scientific calculator, just one click, you'll get this answer. If you just click this, you'll directly get the answer as like this. That is 1.842 at the angle of minus 1.405. So here 1.904 at the angle of 1.7314. Here also 1.904 at the angle of 1.7314. Here also 1.842 at the angle of minus 1.405. This is how you need to formulate the Y-bus matrix. Assume next, what is the next step? Assume the initial flat start. Flat start that this is given in the problem. V1 is equal to 1.05 at the angle of 0 degree. That is given in the problem. But the V2 is not given. So the old value, V2 or old value, or this is the new value, this is the old value. So whatever it might be, the old value that is not given. So as I said before, you need to start with a flat start. That is 1 at the angle of 0 degree. So next step is that step number 3. So calculate P2 calculated and Q2 calculated value. So why to from the second bus? Because first bus already the values of voltage are mentioned. So now we need to calculate the second bus. P2 calculator and Q2 calculator. So what is the formula? PI calculated is equal to summation K is equal to 1 to N BI R. Okay, so BIR modulus into BKR into YIK cos of theta IK plus delta, that is delta KR minus delta IR. Okay, next QI or QA calculated value is equal to minus summation is equal to 1 to N VIR Next, in the modulus, next VKR, YIK, sine of theta IK plus delta KR minus delta IR. How to calculate? Just to substitute I is equal to, yeah, 2 here, because we are starting with the 2, previous 2. So here P2 calculate is equal to V2 into V1, because K is equal to 1. The iteration K we are taken as 1 here. Next to Y to 1. Next cos of theta 1 2 plus delta 1 minus delta 2 plus here again, yeah, V2 square. We are calculating, say, for example, this is up to is equal to 1 to n, no? So n is equal to 2. So up to 2. Second bus also you need to calculate. So substitute k is also 2 and I is also 2. So V2 square, we directly taken as V2 square into Y22 cos of, okay, cos of theta. So here in this formula, PA cos of theta 22 plus delta minus delta 2, because K is equal to 2, I is equal to 2. This is get cancelled. So you need to the values V2, V1 1.05, Y21, 21 from the thing. Yeah, 904 at the angle of 1134. Okay, 1.904 at the cos of 1.7134, because theta 12 is there now 1.7134. Because all we are taking in the polar format, so better you also take in the polar form, convert into the polar form. Next, V2 1, Y22. What is the Y22 value from this here? 1.824. 1.824 cos of theta 22. What is theta 22? Minus 1.0405. This is get cancelled. So simplifying, you will get the answer by using the scientific calculator. You'll get the answer as minus 0.015 per unit. That is P2 calculated value. We got like this. Next, similarly, P2 specified value is equal to Pg2 minus PL. So Pg2 value not mentioned in the problem. From the problem, if you go back to the problem, P2 value not specified. So that is 0. Anything not specified means you directly take it as 0 minus QL. QL is specified. That is 10. Okay. So 10 at the base of 100. Okay. The QL is mentioned as 10. Yeah, here yeah, it is mentioned as 10 MB. So it is mentioned as MBA. We need to change it to per unit. Okay, actual value by base value. So we are taken. So if anything base value is not given, you take it as 100. And it depends on the problem. So sometimes they will be given, take the base value as 100 like that. So here all it is mentioned in the scale of 90, 10, 20, 30. So all it is mentioned in the scale of 100. So that's why we are taking the value as 100. So 10 by 100. So here it is 10 by 100. Yeah. Sorry. Here PL is 30. Okay. PL is 30. So 30 by 100. So 30 by 100 is minus 0.3 per unit. So P2 specified value is minus 0.3 per unit. Next, change in the real power. Del P2 is equal to P2 specified minus P2 calculated. P2 specified value we already calculated, that is minus 0.3 minus P2 calculated value. What is calculated value here? Yeah, minus 0.1015. That you substitute, you'll get the change in the real power value. Next, similarly, the Q2 calculated, that is change in the reactive power. Q2 calculated is equal to same the formula you need to substitute. Same in the formula you need to substitute. While substituting, you'll get a minus V2 V1 Y12 sine of theta 21 plus del 1 minus del 2 minus V2 square Y22 sine of theta 22 plus del 2 minus del 2. This both get cancelled. Next, substituting the same values. B2 1, B1 also 1. So that's why not mentioned here. We have Y12 from that matrix Y12 or Y 1.904. Yeah, 1.904. Sorry, here 1.904 sine of that angle value minus this B2 is 1 square. Y22 that value you take down from the problem. Sine of theta 22 minus 1.405. Just simplifying by using scientific calculator, you will get the answer as minus 0.157 per unit. Similarly, you need to calculate the Q2 specified value. Q2 specified value is equal to QG2 minus QL. QG2 not given in the problem, so 0 minus QL value, it is given as 10, mentioned in the problem data as 10. So 10 MVA. So you need to convert into per unit. So 10 divided by 100 at the base of 100, you'll get minus, by simplifying, you'll get the answer as minus 0.1. So Q2 specified value as minus 0.1. So change in the reactive power is equal to specified value minus calculated value. What is the specified value? Minus 0.1. What is the calculated value? Already we calculated. Just to substitute it, simplify it, you will get the answer like this. Del Q2 is equal to 0.057. So whether you are getting the same answer or not, you just put it in the comments. So you'll get the change in the reactive power as 0.057. So similarly, what is the next step? Next step is to formulate the Jacobian matrix. So what is the general formulation of Jacobian matrix? Del P2 divided by del 2 into V2 into del P2 divided by del V2, del Q2 divided by del 2, V2 into del Q2 divided by del V2. So V2 is 0 in some books or in some materials. So it will be directly given. So why? Because V2 will be 1 plus angle 1 at angle of 0 degree. So that's why we are skipping this V2. So you just, this is the general formulation. V2 is there. So into del 2 divided by del V2 divided by V2 modulus. That is equal to del P2 divided by del Q. So here we are formulating the Jacobian matrix. So Jacobian matrix del P2 divided by del 2. So whatever the value we are getting, we got in the that del P2 values then P2 value. This you need to differentiate it with respect to del. With respect to del, you will get the get like this V2 into V1 Y12 sine of theta 12 plus del 1 minus del 2 plus V2 squared into Y22. This already, I think this formula already we have seen in our general formulation in the Gauss-Seidel method itself. So same thing. So here, I think delta value is 0. So into 0 is 0 here. So you no need to take this. Okay. So just you need to substitute the values for this. So V2 is 1, V1 is 1.05, Y12 is 1.905 sine of this theta 12. Del 1 minus del 2 is, I think, 0 minus 0. So no need of taking. So 1.731. So while simplifying with the scientific calculator, you will get the del P2 divided by del 2 as 1.973. Similarly, you need to differentiate del P2 with respect to V2. So just with respect to V2, if you differentiate it, okay, so you will get a V2 into V1 Y12 cos of theta 21 del 1 minus del 2 plus 2 into V2 Y22 into cos theta 22. So here V2 with respect to V2 we are differentiating. So this becomes 1. This becomes 1. So no need of mentioning over here. So V2 into, so even though if you mention also V2 is 1 only, but while differentiating this will not come. So V1 into Y12. So here small mistake. So V1 into Y21, like that only it will come. Okay, so here substituting all these things like V2 Y2 1 cos of theta 1 2, this becomes 0 again cos of theta 2 2. Simplifying, you will get the 0.289. Similarly, the del Q2 divided by del 2. Okay, just substituting this term becomes 0. V2 into Y, V2 into V1, Y21 cos of theta 21 plus del 1 minus del 2. Substitute all. So this term will become 0 because cos of 0, sorry, cos of I think at the angle of 0, some 0 becomes 0. Okay, so that's why this whole term becomes 0. Next, just substituting, you'll get the answer like del Q2 divided by del 2 is equal to minus 0.3197. Just to substitute in the Jacobian matrix like this. Next, again, similarly, V2 into V2 is 1, del Q2 divided by V2. So similarly, if you differentiate with respect to V2, okay, here you'll get a minus V1 into V2 into Y21 sine of theta 1 2 plus del 1 minus del 2 minus 2 into V2, sorry, not square here. So V2 because V2 square becomes 2V2. So here now square will not come, Y22 into sine 22. So here, while simplifying, you'll get the answer like V2 into del Q2 divided by del V2 is equal to here 1.66 I'm getting. So you just mention in the comments whether you are getting the same answer or next step number 5, compute del x. That is this Jacobian matrix already we calculated that you need to substitute. Okay, so here why we are taking the inverse means Jacobian matrix J. Okay, J is equal. It will go to previous formulation, then you can understand easily. So this is the formulation. It's a general formulation. Now we want this del 2 divided del 2 into del V2 only we have to get. So this is nothing but equal to del P2 into del Q2 matrix into this same Jacobian matrix will come this side, means inverse. Okay, the whole inverse. The same thing we did here. So whole inverse. So this value is already we calculated. Just okay, substitute it. The inverse. You know how to find out the inverse. A inverse. Okay, 1 divided by modulus of A into adjoint of A. That A inverse. I think you can directly do it in your scientific calculator. I think up to 2 cross 2 matrix you can directly do with your scientific calculator. 3 cross 3 matrix means you need to calculate individually, I think so. So just you need to calculate this inverse matrix. Then you need to multiply. You need to multiply this. Multiply this, you'll get the answers. Final answer as change in the del 2 divided by del V2 divided by V2 is equal to minus 0.14539. 0.0064. So change in the this value, that is change in the phase angle value as minus 0.14539. Change in the voltage value 0.0064. Now we need to calculate new delta value. New delta value is equal to old delta value to change into delta value. Old is 0 because 1 plus J0. So 0 here del 2 is nothing but already we calculated. Okay, this minus 0.14539. Okay, now new delta value or del 2 dash is equal to minus 0.145. Similarly, you need to calculate the new voltage value. V2 new voltage value is equal to old value minus del V. That is change in the voltage. Old value what? 1. What is the change in the voltage? Yeah, change in the voltage we already calculated 0.0064 by using the this Jacobian matrix method. We calculated the change in the voltage. Okay, so 0.0064 you just substitute. So V2 new is equal to 1.0064. Okay, so here by seeing this voltage value itself, you can easily you can understand like whether your answer is correct or not, because change in the voltage value has to come very less value, that is 0.00 some values. that you need to get. And also see, for example, 0.45, very less value. Delta value is very less value. So by analyzing this value, you can easily identify whether the answer is correct or not, whether the solved problem is correct or not. Okay, this is how you need to calculate. Change in the voltage value, you need to calculate. Change in the del value, you need to calculate. Okay, so for even in the Jacobian matrix also we calculated as same, but there the steps are simple. So here Jacobian matrix you need to calculate, and from that we are calculating this new voltage value, change in the voltage value and change in the this delta value, new delta value and new voltage change. So initially you are giving the some voltage, and finally what is the voltage we are getting? What is the change in the voltage we are getting? That we need to analyze from this Newton Raphson method. So very simple. The thing is that calculation, without any calculation mistakes you need to do. And while doing this matrix multiplication, matrix inverse, you need to do it very, very carefully. If you miss anything, the whole problem goes wrong. Goes wrong. Okay. And also while substituting, if you substitute wrong theta 1 value or theta 2 value like that, if you substitute it wrong also, you'll get some other different value. You'll get more difference in the final value. Then the whole, even though your steps are correct, only steps for step marks will be given. Instead of 10 marks, they will be given like 4 marks or 3 marks only for the step and the formulas. Like that only they will award the marks. So while doing, we need to be very, very careful. Okay, so first you need to calculate PA calculated value, P calculated value, Q calculated value, change in the real power, change in the reactive power. Next, you need to formulate the Jacobian matrix. After that, you need to calculate the change in the del del and del V. Okay, phase angle and voltage change in the voltage value you need to calculate, and new value. What is the new delta value and new voltage value? That also you need to calculate at the last. This is how you need to do it for your Newton Raphson method.